In terms of this, what we're going to look at is the following. If you've got this situation here, this is about the reactivity series and how we use the reactivity series. So this is the reactivity series, what you can see on the screen. This is just a list of all the elements in terms of the metals that are placed in order of their reactivity. However, one of the things that you'll notice is there are two elements, so the carbon and the hydrogen, that are not part of them. They're not metals, so why are they included in this reactivity series? It comes down to two questions really. So we'll talk about carbon first and then we'll talk about hydrogen. So with carbon, why is carbon included? How are most metals extracted? Most metals, when you find them underground, they are found as metal oxides. Now, in order to go from a metal oxide to a metal, you need to obviously carry out reduction, so you need to remove the oxygen. Okay, remove the oxygen. If that's the case, if I want to remove the oxygen, then what do I need to do? Ideally I would react it with something. So how is carbon involved? Elements that are less reactive than carbon can be reacted with carbon Tanviro, it's Ahmed Science UK. If you type in Ahmed Science UK, you'll see part 1. Okay, elements that are less reactive than carbon can be created with reacted with carbon to produce carbon dioxide. Carbon dioxide. Now, that's really important. The reason that's really important, which I'll explain in a second, is if you've got something over here, say for example, you've got zinc oxide, and I reacted it with carbon, I would end up producing, that's a bit too big for my liking, if I had zinc oxide and I reacted it with carbon, I would end up producing carbon dioxide and I would have pure zinc. So I would get pure zinc by itself, and that's kind of what Tanviro, I don't make the AQA ones, but the predictive papers, there's no way to know they're accurate until you do the first set of papers. So hopefully what you'll find is that once you've done the first set of papers, you will find that a lot of it will match up. It's usually made based on the past papers that have happened already, and then they use that to look at trends and stuff that comes up and typical exam questions that come up. So these ones are made by a physics and math tutor working with another tutoring company. I make them, and I'm going to make one for just before the exams for the AQA one. I don't want to do a one just yet because I know that a lot of people are doing the PMT ones already. Now, if I go back to this then, so zinc is, if zinc oxide reacts with carbon, I'm going to make pure zinc by itself. The other reason is if you look at hydrogen, hydrogen's included, hydrogen's further down the list. I've only got 3 people, so we need to share this please, boys and girls. If you've not joined, or if you are joining and falling out or whatever, please make sure you stay. If you look at these 3 acids, so these 3 acids, they all have one thing in common. They all have hydrogen in common. Because they've got hydrogen in common, what's going to happen is when I react anything that's more reactive than hydrogen, so say for example iron, say for example zinc, aluminium, anything that reacts with is more reactive than hydrogen, when I react it with an acid, because the acids contain hydrogen ions, the hydrogen will react and you will make something called a salt. So here I will make a salt. Now later on I'm going to come back to this. Later on I will come back to this and I'll kind of show you it and kind of explain what that means. Okay, so if you haven't taken a screenshot, please take a screenshot now. this is kind of one of the things that you need to know. Let me move my face out of the way. So this is why we include. No, Tanvir, I've been teaching for 13 years. I didn't make them in the first few years, but I've been making them for a while. So now going back to this, then the question is about metals. The extraction of metals from ores. The method used to extract a metal from its ore is linked to its reactivity. Yes, Tanvir, they've been pretty solid. Which list shows the metal in the correct order of increasing reactivity? So if I look at my reactivity series and I look at the list, the correct answer, so I've got zinc, aluminium and iron. The one that's going to be at the top is aluminium, then it's going to be zinc, then it's going to be iron. So increasing reactivity is iron, zinc and aluminium, so it's going to be the second one there. Now, what is formed when magnesium reacts with dilute hydrochloric acid? When it comes to dilute hydrochloric acid, so I've got magnesium and it's going to react with dilute hydrochloric acid. Remember I said if anything's more reactive than hydrogen, it will react with an acid. What will I make? So what is formed? I'm going to have two things that are formed. The two things that are formed, can someone tell me in the chat? Someone tell me in the chat. So I'll write the full, good, well done Deliana. It's going to be magnesium chloride. So when I have magnesium plus hydrochloric acid, I am going to remove the hydrogen and therefore I will make magnesium chloride and hydrogen gas. So whenever I have a metal and it reacts with an acid, I will always make a salt. This is called a salt, and I will have a hydrogen gas produced. So metal plus acid will always give me a salt plus hydrogen gas. Now, next one, a sample of copper oxide is heated with excess carbon to produce copper and carbon dioxide. Write a balanced equation for this reaction. So the first thing I'm going to do is I'm going to write out the reaction. So it's copper oxide, CuO, plus carbon, gives me carbon dioxide plus Cu. Now, how do I balance this out? Well, I need two oxygens, so therefore I'm going to write a 2 in front of the copper oxide, and then I need to write a 2 in front of the Cu, and then that would give me a balanced equation. Okay, so I write down the equation first and then I look at how to balance it. So obviously I've got two oxygens, that means I need two copper oxides, and then because I've got two copper oxides I will produce two coppers. Now the next thing that I want to kind of look at is this question here. If 10 grams of copper oxide is used, calculate the maximum mass of copper that can be obtained. They've given me the molar mass of copper oxide and they've given me the molar mass of copper. Now the way to kind of work at this or look at this is to remember this phrase. The phrase is, my mother really nags. My mother really nags. So M stands for mass. Mr is the relative formula mass times N. So that is the number of moles. No, this is C1, Aliona. And this is the relative formula mass.
Yes.
Right, so when I've got this, what I can do is I can look at this and I can use this to work out the number of, or the maximum mass of carbon produced. How do I do this? Well, I need to first of all work out, there's two steps to this calculation. Number one is I've got to work out the number of moles of CuO. To work out the number of moles, if I look over here, I need to do the mass divided by the relative formula mass. So that's going to be 10 divided by 79.5, and I put that into my calculator and I get 0.12. Yes, Fizz, this is combined. 578. Again, pen's a bit too big. So 0.12578 moles. And then what I can do is I can use this number of moles, because I've got 2 moles of copper oxide and I've got 2 moles of copper. The number of moles are exactly the same. No, AB, I think that's a good practice. There's absolutely no reason for that not to be the case. So when you've got this, you've got the number of moles of copper oxide. Now, because the number of moles is the same, that's actually 2 moles, or 2 times the number of moles for copper oxide, and that's going to be exactly the same as the copper, because if I look at the balanced equation, they're both exactly the same. So now I want to work out the mass. So step 2 in this, again, if I'm looking at the mass, I need to do the relative formula mass multiplied by the number of moles. So that's going to be the number of moles, so the mass of Cu is going to be the number of moles of copper, which is 0.125, hey me, 12578, multiplied by, and it's going to be the molar mass of copper, so 79.5. I multiply those two things, sorry, I lied, it's 63.5 is what I meant, and that's going to give me an answer of 7.99 grams. So when I have 10 moles of copper oxide, I do those 2 steps and I can work out that it's going to be 7.99 grams. Okay, so the formula that you need to remember, and it's just about manipulating this formula, is mass, mR, and the number of moles. So the number of moles is equal to the mass of an object, or mass of a substance, in grams divided by the mR, the relative formula mass. Okay, now that's kind of that question there. And then finally, going back to this, explain why aluminium is extracted by electrolysis. Aluminium is extracted by electrolysis rather than reduction with carbon. So remember, if I go back to this, anything that's below carbon in the reactivity series, extracted using reduction. In other words, you react with carbon. And if it's above carbon, that is extracted using what process? Tell me in the chat. Extracted using, what's the process for extracting anything above carbon? Good, well done, Fizz. Extracted using electrolysis. Okay, so that's there. Like I said, this is going to be uploaded to YouTube, so if there's anything that you're not sure of or you want to rewatch, then absolutely that's fine. Go back and have a look. So, first of all, how do I kind of explain this? Well, why can't I use reduction? Why do I have to use electrolysis? So the first thing I need to say is aluminium is more reactive than carbon. If aluminium is more reactive than carbon, which means it has a tendency to form strong bonds with oxygen. Okay, so far so good. Now, aluminium is more reactive than carbon. We've said that already. Therefore, carbon cannot reduce aluminium. Carbon is not reactive enough to react with aluminium oxide, because aluminium is going to hold on to that carbon atom, that oxygen atom, a lot better compared to carbon. Yeah, right. So boys and girls, this is question 5. It's about 8 marks. As you can see, most of it is about the basis of understanding why the reactivity or how the reactivity series is used in actuality. In other words, why is carbon there? Why do we use carbon? And how does knowing where hydrogen is help us to understand the reaction of metals with acids? Fizz, I think you've asked that already. This is C1. This is C1. Paper 1. C1, paper 1. Right. So, question number 6, very quickly. If you've not shared this, boys and girls, please share this live with someone. At least one person that you know. At least one person that you know. So, this question is about energy changes in chemical reactions. So, first of all, the students investigating the reaction between different metals and sulfuric acid. So, it's different metals and sulfuric acid in a set of test tube reactions. Yes, Angel, I will, don't worry. So, they measure the temperature change for each reaction and observe the rate of reaction. Student uses 5 different metals, so they use magnesium, zinc, iron, copper, and aluminium. What is the independent variable in this investigation? No worries at all. That doesn't mean that you don't join the live though, yeah? That will break my heart if more people start going to the YouTube after all this. Good. Fizz, well done. It is different metals. You're absolutely right. I just want to kind of look at this first very quickly. So the variable that changed in the investigation, what do I call it? What do I call the variable that I change in an investigation? This is applicable to all 3 sciences. What do I call the metal that changes? What do I call the variable that changes? Good, well done, Rayan. This is the independent variable. Let me rub that out real quick. So this is the independent variable. The variable that you will measure as a result, or the variable that is measured. So the second one, what's that going to be? What's the second one going to be? Dependent. Well done, Fizz. Well done, Rian. So dependent variable, and in the final one, the things that you are keeping the same are therefore going to be called the what? Well done, Fizz. You kind of guessed. Good. Well done. Control variables. So these are the definitions for the variables. You need to know these. Like I said, these are applicable across all 3. So if you haven't taken a screenshot, take a screenshot really quickly and then you can crop my face out on a later date. Okay. So what is the independent variable in this investigation? Fizz, I think you've said it already. The independent variable is the metal used, or the different types of metals. Now, give one variable that the students need to control to ensure the results are valid. What are they actually doing? They're trying to see how the metals will react differently to sulfuric acid. So what is one thing that they need to control? What is one thing that they need to control? They do need to control temperature. Well done. What else do they need to control? Think of all the different things that you could control in this investigation. The concentration of what, Rayan? You're right, the concentration of what? Concentration of what? The mass of the metals. Good, very well done. So you could have, so let's start writing these down. You could have mass of metals. You could have the surface area of metals. You could also have the temperature, volume of the solution, concentration of sulfuric acid. Good, well done. Volume / concentration of acid. Good. So all of these things are going to be control variables. Any one of them will get you the mark. Okay. Just be careful. Don't. And I know you guys wouldn't, but just be careful. Don't use the word amount. Okay. Don't use the word amount. Now, next one. The student records the temperature change for each metal reacting with sulfuric acid and completes the table below. So they've got magnesium has got. Just before I even look at the question, I'm just going to have a quick glance at the results and say, right, magnesium is got the highest temperature change, aluminium's got the second highest, and then I've got zinc, which is number 3, iron, which is number 4, and then copper, which is number 5. So that's the order of the metals in terms of how much they change the temperature. Write the symbols of the 5 metals in order of their reactivity, starting with the most reactive, and justify your answer based on the temperature change observed. So which one is going to be the most reactive? So what's going to be the order of these is going to be Mg is going to be placed number 1. What's the symbol for aluminium? Someone tell me in the chat. What is the symbol for aluminium? Someone tell me in the chat. Good, well done. And then what's the symbol for zinc? Someone tell me in the chat. What is the symbol for zinc? Almost, yeah, well done. It's Zn. And then number 4 was iron. What's the symbol for iron? We know what we're doing now. What's the symbol for iron? And then what is the symbol for copper? Fe, good. And then what is the symbol for copper? Good, well done. So when we talk about these, and then Cu at the end. So when we talk about these, we have to first of all, because it's 2 marks, I have to first of all put the order of the metals here, Zn, Fe, I've got Cu, and then why are they in this order? Why are they in this order? The temperature change observed during the reaction will be higher for more reactive metals. That is all I need. Yeah? So, boys and girls, this would be the answer to question 6.3. Now, I'm conscious of time, so I'm going to move on relatively swiftly. If you have any questions, please, by all means, put them in the chat. However, if you are here and you are watching and you are finding this useful, as always, please share the live. The more people that share it, the more people that can access it, and the better it can be. Right, 6.4. So, yeah, no, tell me about it. It's a late one. Right, figure 3 shows an incomplete reaction profile for an exothermic reaction. Now, they've asked us to label certain things. Yeah, Hifsa, I am going to make a my version of an AQA paper using Exampro. So I made one for EdXL just because that's the one I teach at my school, and therefore I kind of wanted my students to have it. But I will make an AQA one for everyone else that follows the channel as well, and I'll put them in a place where you can download it, etc. So hopefully it should be relatively straightforward. Now, when we talk about this, so we're going to label these, the energy level of the products, label it as products. So here I've got my products. These things here, that bottom line is always going to be the products. That is number 1. The activation energy is number 2. So I'm going to draw an arrow from the base of the reactants. So sorry, let me label that first. This is called reactants, and that's number 4. So it's the base of the reactants to the top of the peak, and that is called no fizz. So what this means is, because this is energy on the y-axis, thank you Hifsa, because it's the energy on the y-axis, it just means that the reactants in the molecules themselves, so in the bonds, they have more energy compared to the products. So say for example, I've got carbon and I've got oxygen. So what we're saying is the reactants have more energy in their bonds compared to the products, and therefore what's going to happen is you're going to have less energy in the products, so more energy, this amount of energy is going to be released. Let me talk about it in a second though. So this is activation energy, and then the overall energy change is from the base of the products to the bottom, or sorry, the products to the reactants. So that's number 3. Okay, now this means that this amount of energy is released to the surroundings. Released to surroundings. That's how I think of it. Right. Yes, Hipster, you are correct. Hopefully that does make sense. Right, so boys and girls, now just to kind of give you an overview, obviously this is a predictive paper, so they could ask about either one. They could ask about a endothermic reaction, or they could ask about an exothermic reaction. With an endothermic reaction, the products, notice, are higher, so that means that amount of energy is absorbed, that amount of energy is taken in, whereas with an exothermic reaction, the reactants and the products are lower, so that amount of energy is released. Okay, so I'll leave that on the screen just for a second in case you want to, yes, Litha, this is chemistry paper 1 for AQA, so I'll leave this on the screen for a second if you want to take a screenshot. And then, so going back to this obviously is an exothermic reaction. Explain how you can tell from the reaction profile that the reaction is exothermic. How do I put that into words? It's very simply the energy level of the products. It's not they gained less energy. I'll talk about that in a second, motives, because it's a very, very common misconception. I will clarify that. Let me just finish writing the answer. Of the products is lower than the energy for the reactants. Now, yes, absolutely. Well done, Elsie. So it's less than the reactants. Now, what that means is every single time, and this is really, really important that you understand this, HIFSA, they haven't released grade boundaries. I'm guessing around 80%. It would be around 80%. But kind of going back to this, when we talk about exothermic and endothermic reactions, every time breaking bonds, so in other words, of the reactants, is always, always, always endothermic. So say for example, it takes, let me change colour, say for example, it takes 1000 joules or kilojoules per mole to break the bonds. Now, making bonds is always, so for example, for the products, is always exothermic. Because it's always exothermic, that means, say for example, this was 800 kilojoules per mole. Overall, 1000 joules is absorbed and 800 joules is released. That means overall more energy is absorbed in this particular scenario, so therefore overall reaction is endothermic. Okay. Wallahi same. Oh wow, you guys are using me as like as procrastination time. I see how it is. Right. Boys and girls, hopefully you do find this useful and you're not just using this for procrastination. But anyways, that's the kind of point I was making. So every single time, now I can flip this. If say for example, this was only, it took, I don't know, 200 kilojoules per mole to break the bonds, and 800 kilojoules were released, overall the reaction would be, because more energy is being released, overall the reaction is exothermic. No worries, it's alright. Overall the reaction is exothermic. Okay, so boys and girls, it is very, very important to understand that it doesn't matter. That's why every reaction profile has an activation energy, because you need to absorb the energy in order for the reactants to break up. Okay, now we are going to start question 7. Question 7 is about electrolysis. So before we start question 7 on electrolysis, very quickly, what I'm going to ask you to do, if you have not done this already, we've only got 16 people tonight. We had 60 last week on Monday, not last week, this week on Monday. So please, 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 if you've not shared this live, please spend a second. Hopefully it doesn't take you very long, but share this live with someone, please. Share this live with some year 11s that you think will find it useful. Do it very quickly for me. Right, okay, so should we do this question on electrolysis then? Thank you for those people that shared it. Well done KP, well done Fizz, well done Hifsa, well done Kate. So let's have a look at this then. Water with dilute sulfuric acid. So this electrolysis of acidified water produces hydrogen and oxygen gas. Following apparatus is used. You've got water with dilute sulfuric acid. You've got 2 graphite electrodes, a suitable container, a power supply and test tubes. So what does that look like as a diagram? What it would look like if I've got my power supply here, so that's my power supply, and I've got it connected to 2 electrodes. I can put those electrodes here, one of them's there and one of them's there. I've done them in this particular direction for a particular reason. We know that both the products of this are gases. So in order to catch the gases, one of the things that you need to do is you need to set up a test tube. So how do I do that? Well, I've got my electrodes. I set up a test tube around the outside of the electrodes, and then I put this all inside a container and I fill up my container with my solution. And as I fill up my container with this solution, there will be solution in these sections here, and what it will do, violation detected, end live now to avoid suspension. I keep getting told to end the live. Oh, is it fake? Ah. You say that, but basically, thank you. It's crazy because I did actually get a notification saying that at the beginning to say that there was a violation, so therefore I needed to end it. Right. Okay. So if I carry this on then, what I've got, you idiot. I mean, if you don't want to be here, just leave. Why are you trolling? So, boys and girls, if I've got this then, so what will happen is, if I've got this kind of diagram, now I'm not gonna write up the answer just because it's a long 6 marker, and I'm just gonna talk about the answer instead. But this would be the setup for the diagram. I'm going to label it really quickly so you can see what you are actually looking at. So I've got my electrodes here, and I've got my solution here, I've got my container, and I've got my power supply, and once I've got all of this, also I've got my test tubes. Right? As this reaction carries on, there'll be bubbles of gas that form, and they'll catch in the top of this test tube. Okay, so one of them will collect hydrogen gas, one of them will contain oxygen gas. So correctly set up the container with dilute sulfuric acid and water. I've done that. Position the graphite electrode test tubes to collect the gas. So I have So I have done that. Connect the power supply to the electrodes. I've done that. Now, process. Electrolysis of water breaks it down into hydrogen and oxygen gas. So, electrolysis of water breaks it down into hydrogen and oxygen gases. Gas collection is done using test tubes. Okay, and then the next bit is, this is for paper 1M, and then finally, how do I test them? So the last part of the question, describe how you would conduct a test to confirm the presence of these gases. What is a test for hydrogen gas? Someone tell me in the chat quickly. What is a test for hydrogen gas? No, you don't need to hold them over, Hifsa. Squeaky Pop, well done. Wingstop Warrior, well done. LC, so I've got Squeaky Pop. And what's the test for oxygen gas? What's the test for oxygen? Someone tell me in the chat. Honestly, I couldn't tell you at this point in time. I will make my own version for AQA, but also Dr. Azam or GCSE Science, he's already made them for separate. If you're doing separate, I'm going to do a combined version. Good, well done, LC. So they will relight a glowing splint. So the two tests that you need to know are, for hydrogen, you will have, it will make pop sound when you bring a lighted splint towards the gas, and oxygen, it will reignite a glowing splint. Okay, those are the two tests that you need to know. While we're here, can someone tell me the test for carbon dioxide? What is the test for carbon dioxide? Tell me in the chat quickly. Good, well done. So turns lime water cloudy. Turns lime water cloudy. Well done. Good, well done LC, well done M, well done Hart, well done Lewy. Right, so next question. Oh, way too zoomed in. Let's have a look. Yeah, we're good. Next question then. I think this is the 8 and 9. 8 and 9 are the last one, so it's just last two pages really quickly. Let's have a look at this. So, couple of things before we get to question 8 really quickly. So this question is talking about making soluble salts. How do you make soluble salts? So this is from Save My Exams, but very simply, you take your soluble salts and you add them to water, and then you stir it. You keep adding it until there is an excess, and I'll talk about why in a second. Once you've got that, you will form a precipitate. So the salt will no longer, won't dissolve, and therefore you will form a precipitate. You then have to carry out filtration. When you carry out filtration, you pass it through a filter funnel, and you will end up with, in the filter funnel itself, you will end up with precipitate. So that in here is going to be your precipitate. So once all the water's gone through, once you've done that, you use the really important step. You have to use distilled water to wash the precipitate and remove traces of the solution. Once you've done that, as in once you've washed it, you let it dry in an oven. So you dry the precipitate in an oven, and you can keep it relatively low. Did you know I did the USC Ice Bucket Challenge? Oh, nice, FC. Right, Ice Bucket Challenge. I did a video of it like years and years ago. I think like 13 years ago when I first started teaching. So yeah, that brings back memories. Anyways, that is the process for making a soluble salt. And I know it's not very easy to see, but hopefully once you're watching the video, you can kind of pause it and go through it. But also, it is also available on Save My Exams. Now, last thing I want to talk about before we do the question is there are 4 different separation techniques that you need to know. The first one is called filtration. So that's when you've got an insoluble salt. Sorry, insoluble solute. You use filtration. That's when you want the insoluble solute. Okay. Now, next one. What's this one called? What's this method called? What's the separation technique called? Tell me in the chat quickly. Good, thank you very much, sir. So this is called distillation. Now, why would I use distillation? What am I actually after? Good, well done, LC. Well done, Wingstop Warrior. Why would I actually use distillation? What am I trying to get? What is this called? What is the scientific name for the water in this situation? Not distilled water. I mean, this one was called the insoluble solute. What am I after in this situation? That's so LC, what you just described is fractional distillation. It's a version of it. For distillation, what I'm actually after is the solvent. If I want the solvent, so the liquid that is doing the dissolving, I will use distillation. So I can use this for alcohol. If I've got something dissolved in alcohol and I want just the alcohol, I can use this to get just the solvent by itself. So in this situation, obviously they've got salty water, they will end up with just pure water. And this one here, what do we call this? What do we call this? I've got an evaporating dish, I've got mixture, I've got wire gauze, tripod stand and a Bunsen burner. What's the separation technique called? Crystallization. Well done, R. Crystallization. And what am I using this to get? So the first one was the insoluble solute. The second one was solvent. For the crystallization, what am I actually after? I'm after the salt in the solution, and the salt is called what? It's the solute, but what type of solute is it? Someone tell me in the chat. Do you know what? Because this is uploaded to YouTube, I might just start making up answers because you can't see the chat in the YouTube video. So I might just be like, oh, well done, Hifsa. Good, well done. It is soluble, LC. I didn't make that one up. If you're watching on YouTube, this is called the soluble solute. Okay, LC did actually answer in the chat, guys. And then the last one, this method is called chromatography. Chromatography, and this is used to separate out dyes, okay, to separate inks and dyes. Okay, so these are the 4 separation techniques that you need to know for AQA combined and separate science. So what is the purpose of adding excess solid to this solution? Ultimately is just to make sure all the acid has reacted. Why is filtration used in the process of making soluble salts? Filtration is used because we are trying to remember, if I go back to this, why do we use filtration? Because we want to we want to get the insoluble solute. So to separate the insoluble substance or solute from the solution. Now, this particular example uses copper oxide reacted with sulfuric acid to make copper sulfate. Complete the word equation. So if I've got copper oxide reacting with sulfuric acid, and I make copper sulfate, and then the final thing that I make is water. Okay, so that would be the word equation. When does study leave start? Percy, the exam papers, the PMT exam papers are uploaded. I've made them as a playlist, so hopefully you should be able to just watch them one after the other. Yeah. That does mean that I'm probably going to lose all the people that are already watching because they're like, oh, I'll just watch it on YouTube later. But the problem is you don't actually go and watch it later. Yeah, Hifsa, thank you, sir. Unfortunately, a lot of schools aren't doing study leave anymore. They just keep going until pretty much the first exam, or sometimes even up until the half term, and then they'll let you go after the half term. So, describe how a student can prepare a pure Describe how a student can prepare a pure dry sample of copper sulfate crystals from copper oxide and sulfuric acid. This is exactly the method that I described, or rather kind of showed you here. So this is how they would go about it. Okay, so I would add the soluble salts, filter to remove precipitate, wash the precipitate with distilled water, dry the precipitate in an oven. So going back to this, let's put that into words. Add excess copper. In fact, for this particular question, what I'm going to do is I'm just going to put the answer on. I'm just going to copy and paste the mark scheme, just because it's a little bit wordy and we have gone through it, and I'm conscious of time because I want to finish up before 9 as well. Not because I don't like you being here, just because I need to get ready for tomorrow, because school has started. How have people found their first day back at school? Tell me in the chat. Elsie, you can. There's no reason for saying leave on a windowsill to dry, or leave in direct sunlight to dry. That is absolutely fine as well. Yeah, don't worry about that. Yeah, sir, we were back today. Hi Lily. We were back. Ours was the first day today where the students were back in. We had inset day yesterday, and then we started today properly, officially. Right, boys and girls, we are going to do... Yeah, I know, tell me about it. I mean, we did get 2 weeks, so I can't complain, but, you know, yeah, it was a bit of a shock to the system. Not going to lie to you. Right, boys and girls, last 4 questions. Before we do the last 4 questions, if you've not shared this live with someone, please make sure you share this live with someone, please. Someone that will find it useful. Even if they join for like 5 minutes and then realize they need to follow the channel, that's absolutely fine as well. Or they will understand that they can get the YouTube videos, find the links for the YouTube videos on the channel. Please follow and share. Right, last one then. Let's have a go at this and then let's go to bed because we've got school tomorrow. What is the difference between a strong acid and a weak acid in terms of ionization? Now, I pasted this in already because I wanted to talk about this. When we've got a strong acid completely dissociates. That's the key thing. So a strong acid will completely dissociate when you mix it into water. So examples of this are things like sulfuric acid, hydrochloric acid, and nitric acid. If you are doing AQA, those are the 3 that you need to know off by heart. Okay? Good, well done, Bob. Whereas weak acids are partially dissociated. So they'll separate and then they'll rejoin, and they'll separate and they'll rejoin. So the things with these ones, so for example, ethanoic acid, which is vinegar, and citric acid, which is the acid found in fruits. Lily, this is higher round foundation for this bit. I'll tell you which bits aren't. So ethanoic acid and citric acid are actually weak acids, okay? And then the second part of this to understand is the pH scale. So if I go from 5 to 4, I've actually increased the concentration 10 times, okay? So I've increased the concentration of H+ ions if I go from 1 pH number down. So if I go down by 2, I've increased it by 100. And if I go down by 3, I've increased it by 1,000. Okay? So it's a logarithmic scale. In other words, it goes up not just by 1, it goes up by a factor of 10. Now, going back to this then really quickly. What is the difference between a strong acid and a weak acid in terms of its ions? In terms of ionization, strong acid ionizes completely. In water. And a weak acid ionizes partially in water. Okay, next one. What happens to the hydrogen ion concentration when the pH of a solution decreases by 1 unit? It increases by a factor of 10. This is AQA, Louise. Factor of 10. And then next one, a student has 2 solutions of hydrochloric acid. Solution A is 0.1 moles per decimeter cubed, and solution B is 1 mole per decimeter cubed. Which solution is more dilute? Well, in this situation, it's going to be solution A is more dilute. How do I know that it's more dilute? Because is more dilute. How do I know that it's more dilute? Because it contains fewer molecules of HCl acid per unit volume. Per unit volume, okay? And then finally, write the word equation for the reaction between sulfuric acid and sodium hydroxide. Well, the word equation is just going to be sulfuric acid cycloabdile. I don't think you can. It is a reality of the situation. You could basically, if you are getting a 7, or you could teach yourself A level, but you wouldn't get a grade, a particularly strong grade, if you just got a 4. So people that are getting 7s, I'm gonna finish it. Unfortunately, Flower, I'm finishing it in about 2 minutes, or a few minutes rather. If you need to be aiming for about a 7 at GCSE in order to get a C at A level, in reality, yeah. Grow and Gomes, after solving, can you please go through it again? What do you mean, sorry? Do you mean the whole paper, Grow and Gomes? Fair enough. If you get in a tutor, it might be slightly easier, but you do need to understand that it is quite a step up, and I'm not putting you off, I'm just trying to make sure that you understand the reality of it and set your expectations. You will need to work particularly hard to improve in order to get a decent grade at A level. Louise, is there still time to improve my GCSE? Yes, of course there is, Louise, and I'm not just saying that. With GCSE, it's just about content and revision. You know, if you put the work in between now and the exam, but I mean actually put the work in, you can absolutely get yourself a 9. It is very, very difficult, but it is there is no reason why people can't if they put the work in.